Hi, it's Katherine from Spark Academy, and in this video we're going to be looking at tree diagrams. So to begin with, we're going to be looking at a coin that's biased, so the probability of throwing a head each time is 2/3. The reason we're saying it's biased is normally when you throw a coin, the probability is equal, so it's a half to get a head or a half to get a tail. So these would be our results. So the probability of getting a head is 2/3, so that means the probability of getting a tail is 1/3, because probabilities add up to 1, because 2/3 plus 1/3 is 3/3, which is 1/2. Okay. Again, we do it the same, so the probabilities will stay the same. This is what is known as independent probability, where the probability stays the same from one attempt to the second attempt. So we want to find the probability, and to do this we multiply the probabilities along the branches. So to find the probability of getting a head, then another head, we do 2/3 times another 2/3. So when you times fractions together, you times the numerators, so 2 times 2 is 4, and you times the denominators, so 3 times 3 is 9. So the probability of getting 2 heads is 4 9s. So the probability of getting a head then a tail would be 2/3 times 1/3, which gives us 2 9s. Probability of getting a tail, then a head, is going to be the same, because the same fractions, just the other way around, so that's 2 9s. Then the probability of getting a tail, then another tail, is 1/3 times 1/3, which is 1 9. So sometimes you'll be asked certain questions, so the probability of getting one head and then one tail, well, you could either get a head followed by a tail, so it would be 2 9s, or you could get a tail first, then a head. When we use the word or, we add the total probabilities together. So after we've times them, we would take these totals at the end and add them together. So it would be 2 9s plus 2 9s, which is 4 9s. So that is independent tree diagrams. Now we're going to look at dependent, where the probabilities change from one event to the next one. So Charlie has 10 counters. 3 of the counters are blue and 7 of the counters are green. So we're going to begin by putting that on our tree diagram. So it's, because there's 3 and 7, that makes 10 altogether. So 3 out of 10 are blue, 7 out of 10 are green. It then said he removes a counter and notes the colour and does not replace it. And then he chooses a second counter. So that means if he's chosen a blue on the first attempt, there will now only be 2 blue left in the bag. So also the total has gone down by 1 as well. So instead of being 10 counters in the bag, there are now 9. But with the green, because they chose a blue, there would still be 7 green. But again, it's out of 9 because there's now only 9 counters. To check you've done this correctly, the numerators on the top should add up to one of the denominators. So 2 plus 7 is 9, so we know we're doing it correctly. If instead they've chosen a green, that would mean there would still be 3 blue counters out of 9. But if they've chosen a green, there'd only be now 6 green counters. Okay, again, 3 plus 6 is 9, so we know we've done this correctly. Okay. So now we're going to work out all the probabilities. So probability of blue is 3/10 times 2 9s, which gives us 6/90. Now obviously this could be simplified, but to make it easier, simplify at the end. Or with probability, you will get the marks if you don't simplify unless they specify. So probability of a blue then a green is 3/10 times 7 9s, which is 21/90, or 21/90ths. Then green and blue, it's going to be the same answer, just the fractions are the other way around, so 21/90. Then a green, and then a green is 7/10 times 6 9s, which is 42/90. So now we can answer some questions. So the probability of getting the same colour means either 2 blues or 2 greens. So we're going to add 6/90 plus this fraction down here, 42/90, because that's 2 greens. So that would give us 48/90, which at this point, this is when we would simplify it. The probability of getting a blue then a green in any order would be 21/90 plus another 21/90, which is 42/90, which again we can simplify, which gives us 7/50. So that's all for now, but if you have any further questions, feel free to ask in your lesson.